Hello, team. Today, I am doing more of this. I'm trying something different. So, if you actually like this, give me a thumbs up. Let me know. If you don't, let me know in the comments. I would like to hear your thoughts on that. But that's not what we are actually here to do today. Today, I want to look at this. This is the challenge. This is a challenge from exorcism.org. It's called the Hamming Distance challenge. So the idea here is that you get two strands of DNA, okay? And based on the differences within that, that count equals something called the Hamming distance, okay? So at its core, it's just a comparison between two strings. In this case, we are comparing DNA, but we could be comparing anything, right? I'm going to do that over in CodePen, which is where I prefer to do these kinds of challenges to get them started. And I've moved their function in here and restructured their tests using console.assert, which I've talked about in the past. So if this is your first time seeing that, I do have a video. Okay, check that out. But here we are. We have tests that compare similar strings. And down here, we have tests that compare strings that are not equal. Okay, different length strings. Because in this case, you have 4 letters in one, 3 letters in another. How do you compare it, right? Do you compare it so that it compares to the end? Whoops. Or do you compare it so that it's to the start? There are just so many questions there, especially when it comes to DNA. So we just disallow that completely, okay? And on that note, refreshing this because I think I might have messed it up. No, I didn't. We are going to totally get started on this. To start, I'm going to grab this this error message because I want it right here, okay? We aren't going to use that just yet, so I'm going to comment that away and drop to a new line, okay? Right here I have count. Count is going to be something that we use a lot of on this one. And to start, I'm going to use a map, okay? It feels weird to start with something with something that isn't simpler, but follow me along and I'll show you why, okay? So up in the arguments, we have strand 1 and strand 2, which are the two arguments past the strings that we get, okay? And this strand, at least the first strand, is going to be passed into map. Now, you cannot pass strings to map. Instead, what you need to do is you need to split them, okay? The easiest way that I've found to do that is just to do it this way, okay? So I just spread them into an array, and it works quite well. And then inside of here, we have letter and we have index. For this one, we need both, okay? Because the index is going to be how we get the right letter from strand 2, okay? So index is there. Right down here, we have a conditional, okay? If strand 2 index, so there's that index, right? We're getting the right letter according to where we are, does not equal letter. We could have also gone strand 1 index, but we have letter, so let's just use it, okay? But if they are not equal, return true. And that might feel a little bit weird, okay? Returning true here is because we want to count the number of differences. And this right here indicates a difference between the two strings, and we want to capture that. So we're returning true. And then down here, return false. Could you spell it right? Yes, I could. Could you have put this in an else statement? Yes. My advice is don't, because maps should always return something. And this is just a little bit cleaner, okay? So that should work. Now, if I run this, you're going to see that we get, at some point, it breaks. And so I need to go and check and see what I did. Oh, it's because I'm not done. I'm getting ahead of myself. Racing along, doing the thing. The map returns an array of true and false. That's a good start, but we only care about the truthy bits. So let's filter those out using capital B Boolean, okay? And then down here, we're going to return count.length, okay? Because after we get done the filter, we only have an array of true values, and that indicates differences. So we are going to count them, okay? Using length. Count is probably the wrong variable name here, but now clear this out, hit run, and there it is, okay? Don't worry about the red, okay? The important part is that we don't see anything related to single letter identical strands or empty strands or anything like that. These are all should have thrown an error. And that is absolutely true because we passed in some information and it tried to compute. And of course it returned something, right? Which is wrong. We don't want to do that. So that's where our error message comes in, okay? Right here, we're going to set up another if. This is going to be strand 1 dot length not equals strand 2 dot length. There we go. Dropping the error message inside of it. So if these are not the same length, we're going to throw that error. And at this point, now it should work unless I missed something. And thankfully, I did not. Okay. So we have a working function. It gets the job done. All the tests pass because there is no red. If there's no red, you're in good play. You're in a good place. Okay. But we can do better. Okay. And the way that we do better is by refactoring. Now that we have a passing test, it should always pass. Okay. So we can go back and clean this up. As an example, this conditional, every time we're doing a conditional where you're returning true or false, well, you should just return the condition itself. You don't really need all the if statements. Just return and run. Okay. That should give us test 6, which is a pass. Okay. So already we're simplifying it, but the thing that I don't like about what we've done here, and the reason that I started with map, is because I have two loops. I have the map, and then I have the filter. And those two things take power, right? You have to do the work twice in order to get one piece of information. That's not really where I want to live. So every time I see this pattern, where I do a map and a filter or some sort of chaining around these array methods, I like to change it up and use something simpler, okay? So right here, copy, bring it down. Excellent. We are going to change this to be let count equals 0. And we're just going to increment that. So we're going to add 1, add 1, add 1 to get our final count, which means we're only ever returning this, okay? Right below it, we're going to use a standard for loop. So let index equal 0 and index less than strand 1 dot length and index plus plus, okay? And then inside of there, we have that condition. So that is, let's just go up and grab it right here, okay? Pasting it in. Excellent. Almost lost my place. Good. Okay. So because we've changed some things, we need to change this as well. So we no longer have access to letter. We need to go strand 1 index, strand 2 index. In this case, we need to go to that different syntax. Okay. And we don't return. We just go count plus plus, or count equals count plus 1, whichever one is more comfortable for you, okay? But now we're only tracking the differences. We don't need to track the OK values. And if we run it, we should get test 7, which we absolutely do, okay? We can do some other stuff with this. So copying, bring it down. Instead of this, we can go with a forEach. So we could go back to strand 1 and do forEach, okay? And the forEach is kind of the exact same thing as the map. So if I go up here to my map, I grab all of this, just like so, copying it, bringing it down, pasting it in, and fixing it. Comments. Comments are going to be the devil for me, but here we go. Okay. So we have that letter, that index. We are no longer returning anything because forEach doesn't return. Okay. So don't get caught by that. And then again, count plus plus, we can get rid of the for loop now. Okay. And run it. Does it work? Unexpected. Oh yeah, this is a tricky one. Okay, if you see this, it's because I'm missing a semicolon here. I don't know where the space is coming from, but right here, semicolon. Okay, it is expecting this line to blend into this because of how the spreading works. So don't forget your semicolon. Okay. Now if you run that, test 8 should be good. Okay. Excellent. Now, forEach, does it work? Absolutely it does. But maybe we want to use reduce because I love reduce. Okay, I find that it's really just a fancy loop. Okay, and let me show you what that means. Right here, bringing it down, pasting it. So I'm going to change this to reduce. Now, if we were doing this using the for loop, we might have the accumulator right here. Okay. So our count is now called accumulator, but we don't do that with reduce. We put it inside of here. It's our first argument. Okay. Our second argument is usually called the current value. We usually use current for that. Okay. Index we still use. We change the inside. So we go, this is the current value and this needs to change. Okay. So right here, instead of count plus plus, we go return because the reduce method, the callback should always return the accumulator. Very important. Always return the accumulator. In this case, it's accumulator plus 1. And if that doesn't pass, then return the accumulator. Okay. Again, always return the accumulator. Always. Then from here, we capture it. Okay. Just like this. Okay. All of this is pretty fancy, but let's go and check to make sure that I didn't miss anything. And I didn't. Oh, actually I did. Okay. So if you remember, I had a 0 on here. This was 0 like this. Okay. That 0, where does that go? Well, that 0 goes right on the end as the second argument to reduce. This is our initial value or our starting value. Okay. So at that point, now I can back this out, run it, and test 10 should pass, which it absolutely does. Okay. Again, we can clean this up a little bit. I was about to say reduce, but we can clean this up and make it a bit of a one-liner for this condition and just kind of do this thing, right? Where test 10, test 11 is passing. We could even just go return, okay? So return directly, getting rid of this count. We don't need that anymore. Run it. And test 11, test 12 now passes, okay? And we are in really good shape here. So I want to leave you with just one little extra bit, which is kind of unrelated to the challenge, but I feel like it should have been an interesting bit, right? But before that, if you like what you're seeing, again, like and subscribe, okay? Lots of stuff coming, and I love to see your comments. Always love reading your comments, so please do that. The part that I want to talk about finally is the fact that we are working with DNA, okay? Which assumes that we only use these 4 letters. Now, this isn't something that Exorcism did, okay? They didn't force these letters, which means that this string could really be anything, right? There could be random characters in here. There could be a Z or a Z, depending on where you're from. There could be a B. There could be an M, right? Lots of different letters other than these 4. So maybe we write a test for that and we double check our work. Okay. Over here, scrolling right down to the bottom, after the final test, but before our group end, we can add a test. That test looks like this. Okay. We are testing to make sure that there are no random characters in here. And that means exactly that. So B is not part of those 4 standard letters inside of DNA, but it could be anything. Tests don't have to be fancy. Okay, I could have just done B versus A as an example. Okay, just to keep it nice and simple. In fact, I'm going to leave it like that. So live coding it. Okay, if this throws its error, I should return this string. Now, that looks a lot like this. So if we scroll back up, right after our first error, we check for our second one. Could we have done our second one first and our first one second? Probably, right? They're both errors. So if one catches, we don't need to skip to the next, right? But considering that this takes more power than this feels like the simpler test. The simpler test should come first, just because it's less intensive. Okay. So here we get both strands and we spread them out into a single array, because if any letter in there does not match our ACTG, okay, if it's not included, then we're going to throw an error. Okay. Which means that now we should be able to run this. Everything should still pass. It absolutely does. And we are in really, really good shape. Okay. Now, to test the theory, if this became G, right? It's not matching, but it's not right either. Okay. We should get an error, which we do. Should have thrown an error. So if it ever starts passing, we're also quite confident that our tests are going to catch that. Okay. Switching back to the B, just like this, running it one last time, and everything is in good shape. Okay. So let's review what we did. Okay. Starting way at the top, we started with a double loop, right? We started with map. We sent it through filter. That gave us a length. It works. Okay. A little bit of a complex conditional in the middle. So we made that a little bit cleaner, right? But it was still 2 loops, which means that it was time to switch. And for me, I usually start with just a regular loop. It keeps things nice and simple, right? So that for loop, we checked it. If it catches, then we increment our counter, kick it out the door, and the test pass. Okay. We could also use a forEach. So forEach is pretty much exactly the same as a for loop, just structured different, right? We did that. We incremented, kicked it out the door, passed. Okay. And finally, we finished with a reduce. Okay. And that reduce keeps it nice and simple. I really like reduce because everything is in there. And if you wanted to, yes, you could name accumulator to count and current to letter and do all that. But for me, reduce is just a really fancy form of a for loop. So coming to grips with it, really nice. We finished off by adding an extra test just to make sure that we were testing real DNA. I mean, could we test any string with this system? Absolutely. But the challenge was to test DNA, so let's make sure that we're actually getting DNA. And that's it. Hopefully that was a bit of a short one, but some really good, fun stuff in there. Again, comment if you found it interesting. I really do enjoy reading those comments. And I will see you in the next one.